Welcome to Whiteboard Wednesday. My name is Nimrod Reiss. I'm the Product Engineering Manager for AMBA and MIPI VIPs, and I'm here to talk to you about the challenges of verifying a coherent interconnect. So when I talk about a coherent interconnect, I'm talking about an interconnect that supports masters who have a cache within them. And this adds a whole new layer of complexity. So in my previous video, I've discussed the challenges of verifying an interconnect. And it's important to note that these challenges don't go away since it's a coherent interconnect. All the challenges I will talk about today are on top of the challenges already existing in a regular interconnect verification. So the first challenge I would like to talk about is snoop filtering. So we have a lot of mechanisms in order to optimize the way the interconnect snoops the masters. And by snooping, I, of course, mean a transaction coming from the interconnect to the master to get data from its cache. So snoop filter is an optional component which contains data on which cache line exists at which master. Now, you need to track all this information and make sure that if you implement such a component in your design, you need to know that it's working correctly and it's snooping the correct master. So some designs implement a selective snoop filter. And by selective snoop filter, I mean a snoop filter that is not active for all transactions. A certain type of transactions go through the normal process of being snooped to all available masters. And some transactions go to specific masters according to the snoop filter. So we need a way to configure that. Another challenge can be stop snooping. When I say stop snooping, I mean under what condition do I stop snooping? So I can always have a naive implementation where every time I get a cache line or a request for a read or a write, I snoop all the possible masters. This is, of course, inefficient. So we can stop the snooping according to data. For example, if we get data, then we stop snooping because we already got the data we want. Or if we got a master replying with was unique, meaning I had the line, I'm the only one with the line, don't worry, so we can stop snooping. We need a way to support all these different modes in order to make sure that we do the match correctly. And we also have a lot of coherent scenarios. I will not go into all of them, but just to name one of them, which is a bit tricky. Let's say we have master A here and master B, and master A issues a write transaction, and it's a partial cache line. So it's not all the data. Not all the byte enables are set. And then we have the data here at master B. So he has to send part of the data. And then it's implementation dependent. Some connect the two transactions and send one to the slave. Some send two transactions. And again, you need to make sure you're aware how your design is configured in order to properly match and to see that no data was lost and the coherency was kept. Another thing I would like to talk to you about is using third-party vendors interconnect. So you might not design your own interconnect. Or you might buy an interconnect from a third party and just add some data paths on top of it. Now, although that design was probably verified by the third-party vendor, you've just added a few interfaces here and a few of your own masters. This also presents a big challenge, because this changes a lot. So you need to make sure that even though your design was bought from a third party, you verify all the new data paths to see they work well with the existing one. The last point I want to address here is throughput and latency. So it's a good thing that the transactions are passing as expected. But another major component is to see the throughput, to see the latency, and make sure that all data paths are checked. For these purposes exactly, we have the coherent interconnect validator, and on top of that, the IWB, the interconnect workbench, which give you good graphical tools, amazing graphical tools to see what is the throughput, what is the latency, allow you to generate your environment automatically, and many other good features. For more information, please go to ip.cadence.com/VIP. Thank you very much. We'll see you next week.